All right, growing and decaying. Growing means it's increasing. And we have a formula. And we're not going to use X because these all have to do with time. So instead of X, we're going to use T. And it's a really simple formula. It's A times 1 plus R to the exponent T. Can you write that down? Underneath, it tells you what each one stands for. A is the initial amount, whatever we're talking about in the story. R is the growth or decay rate. So if something's growing or decaying, there's going to be a percent. We need to change that percent to a decimal and plug in. And then T, of course, stands for the length of time. That could be in minutes, hours, days, years, whatever the unit is that's given. The other one is very similar. So when it's decaying, we are decreasing. Again, we're going to use the letter T. And can you see the only difference between growing and decaying in terms of the formula? Instead of adding the rate, we are subtracting. And the variables stand for the same thing. A is the initial amount, R is the rate, either increasing or decreasing, and T is the time. All right, let's start. Number 1. I think you're going to find these really basic and good to use, so we'll see. Brooke started her career with an annual salary of $32,000. Each year thereafter, her salary increased by 2.5%. Write and use an exponential growth function to find her salary when she retires after 30 years. So read it, annotate. Can you see the important things I'm trying to pull out of the story? The numbers increased and what the question is at the end. So let's start. Is this a growth or a decay question story? So what's the formula for growth? Let's just write it down first. On the side, we're going to write down what each variable is. So that's A, that's R, and T. A stands for the initial amount. Now in this case, we're talking about money. So how much is she getting paid initially? So we're going to put in 32,000. R is the rate that it's growing. What's the rate? Now I know you can do this, so don't forget. We're going to write the percent as a decimal, which means we take the decimal and move it 2 to the left. So be careful. 2.5%. Bankers really like decimal points, right? Like they really matter. So when we move it, it's 0.025. Can we be careful about that decimal? Sometimes the little things are big, like a decimal point. And then it says, find her salary when she retires after. So what would T equal? Use your calculator. We're going to round to the nearest cent. So 2 numbers after the decimal. The last thing we're going to do, did you get $67,122.16? The last thing we're going to do is write a nice, complete, simple sentence. All right, let's start with number 2. In 1995, a magazine had 14,000 subscribers. The number of subscribers increased by 40% each year thereafter. Write and use an exponential growth function to find the number of subscribers in 2016. Is this a growth or decay problem? So, can we start with the formula? And you have to have this memorized. It's not like it's a difficult one to memorize, but you do. In this question, A would be how many initial subscribers? 14,000. At what rate is it growing? So what number should I write down? 0.40 or just 0.4? T. A little bit of thinking. How did you get 21? So 1995 to 2016 is how many years? Subtracted it, right? Now, all we have to do is put it into the formula and use your calculator. Now, we got to be careful here and be a good thinker about how we write the final answer. So first, put it in your calculator. 14,000 Now, when something grows exponentially, it's going to get big over time, right? Especially if it's growing at 40% per year. Did you get 16 million? No? Let's double check. So again, 14,000, 1 plus 0.4 to the exponent 21. I get 16 million. You have to, your mom, you gotta help me figure out what's wrong. Yes, tell me. Oh, is that what the issue is? Okay, so somebody show me their calculator that says exponent. I'll show it on the computer. Oh, yeah. Okay, now. Okay, I'm going to teach you. So you're right. That e to the 7 is telling you that it's in scientific notation. And what it's telling you is to move the decimal 7 to the right. What it's telling you is move the decimal 7 to the right. Did you get that? Okay. And we still get this. Now, it's important to realize, here's a question that would never, ever, ever, ever be a decimal answer. Why not? Why can't you have 16,398,978.68 subscribers? So, for these stories, you might have whole numbers because you're thinking. You can't have 0.5 subscribers, right? That idea. So, there has to be a whole number, okay? Now let's write a good sentence down. All right, can you read number 3, please, to yourself? So when you're done, so again, read number 3, annotate it. So, how much caffeine was in her system to begin with? 150 milligrams. At what rate is it decreasing in her body?
12%. So 0.12.
So, how are we going to write 12%? 0.12. And then T. Notice in this case it's not in days or years, but in hours. How many hours?
8.
Shh, be nice. That was on the video. That was not nice. Okay, thank you for apologizing. Use your calculator. Shh, use your calculator. Is this an example where the answer must be a whole number? Are you listening to me? Use your calculator. Is this an example where it must be a whole number? No, because what we're talking about is milligrams of caffeine. If we're talking about like living organisms or something like that, like people or rabbits, or for things like that, it needs to be whole numbers. So be careful. Did you write down 1 subtract 0.12? So I got 53.945. Did you get that? And now write a good sentence. When you're ready, read number 4.
I didn't get it. I already read it.
Then be patient. So everyone else gets a chance to read it. So we're going to make sure we have some good vocabulary too so we know what's happening. So the half-life of mercury 197 is 3 days. Write and use a decay function to find the amount of mercury left from a 50-gram sample after 20 days. Now, half-life means the amount of time it takes to become half its size. So if something's decaying, it's becoming smaller. And so when it tells you a number for half-life, it says, this is the amount of time it takes to become half its size. Now, when we write this down, we have to be a little bit more careful for half-life. And we'll go through it together. Now, the beginning part's easy. How much is there to begin with? 50 grams. What decay rate do we have? Well, the decay rate is 50%. That's half, right? And 50% as a decimal is 0.5. Did you get that percent from the word half? Half means 50% or 0.5. And then what we're trying to figure out is after how many days? Now, there's going to be a little hook here in a moment, but we're going to start it. So what I want to know is 20 days. So we're going to start with 50. We're going to go 1 subtract 0.5. And here's the hook. Is it losing half its size every day? No, it's every how many days? So I can't put down t. So if I just put down t, that means it's becoming half the size every single day. But it's every how many days? So this is the hook. To write the formula, we have to go t divided by 3. So every 3 days, it equals 1. Or every next 3 days, it's 2, and so on. So whatever the number of days or hours or years is, you have to divide by that number for the formula to work. That's the little hook. So in this case, sorry, what number are you going to put in for t? 20. So you need to put in 20 divided by 3. So let's make sure we use our calculator correctly here. It'd be easy to not type it in correctly. So we're going to go 50, 1 subtract 0.5. Now, when I do the exponent, I need parentheses. Because if you don't put parentheses around the exponent, it's not going to think 20 over 3 is a number. It's going to go to the exponent 20, and then divide by 3 after it. Like it won't think of it as one number. So, parentheses, 20 divided by 3. Now you typed it in correctly. And that whole thing is the exponent of what you're looking for. When you're with the N Spire, those issues don't come up. But the old Ford here, Chevy, comes up. So how much will be left after 20 days? Like a half. So 0.492. Let's write a good sentence. After 20 days, 0.492 grams All right, turn the page when you're ready. All right, sometimes a quantity is constantly increasing at a rate, or it's constantly decreasing. And not just after each year, each month, or day, or hour. It just never stops. It increases, it increases, it increases, and it's not per day, it's not per hour, it's not per year. It's instantaneously always growing, 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 growing. So the formula to the right can be used to find that. And the easiest way to remember this is to say the word, and there used to be a shampoo like this. I don't know if there still is. Pert. Have you ever seen that? It's a green, really cheap shampoo. I don't know if it exists anymore. It probably makes you bald. That's why I've been using too much Pert. P-E to the R-T.
Wait, I'm search it up.
You're going to look up, see, Pert is still a shampoo. So, E in math is not a. E in math is not a letter. It's a number, right? So, in this example, let's write this down so you know. P is the initial amount. E is a number about 2.7. You're going to use the button on your calculator. R is the rate as a decimal. And T is time. Just so you remember that what each letter stands for. Did you find PERT there, Rosie?
Yeah.
Is it still shampoo that exists?
Yeah.
Yeah. In Australia?
And my gem.
Oh, wow. Maybe it was a Canadian thing. I don't know. So, number 5. Let's read it together. We're going to use this. And the key word is continuous or constantly. A garbage dumpster started with 4 pounds of garbage. The amount of garbage increased continuously. And that's that key word to know we're using this formula. By how much? 35% each day from this point forward. Find the amount of garbage in the dumpster after 2 weeks. So, let's start. How much garbage was there to begin with? 4 pounds. At what rate is it increasing continuously? And we write it as a decimal. And T, be careful. The unit to begin with was in days, and then the question at the end says 2 weeks. You can't mix up units. So if the rate is in days, then you have to change 2 weeks to days. So 2 weeks equals how many days? So you have to use 14. So then we write down the formula. P times E to the RT. PERT. In this case, the initial amount is 4. E is in your calculator. And then in the exponent is 0.35 times. All right, use your calculator. This one can definitely be decimals. Doesn't have to be a whole number. Make sure you type it in correctly. You can look at the screen to make sure you're typing it in correctly. That's a lot of trash. Did your answer match it? Are you good with your calculator? Now, write a good sentence. All right, read number 6. Read number 6. Obviously, the formula A equals P times E to the RT. The PERT is only used for increasing in terms of that. I guess no, you could do a decreasing. You just have to change the rate to a negative number. A population is declining. So here's an example. At what rate? If the current population is 16,000, find the population in 8 years. So the initial amount, how many people do we have initially? 16,000. At what rate is it decreasing? And here becomes the important part, that if it's decreasing, for this formula, we're going to use a negative number for the rate. So why is that number negative? Because it's declining, right? If it's increasing, it's a positive rate. If it's declining, it's a negative rate. T is how many years? So the formula is going to be 16,000 E, and it's negative 0.015 times 8. Is this an example where our answer is going to be a whole number? Or can it be a decimal? Does it need to be a whole number? Why is it so dark? I know, it's so dark. Let me turn the blinds over here. So, use your calculator. I'll confirm if you're doing it right. Okay, a little lighter. Are we okay? Again, does this need to be a whole number? Yes, right? So we can't have point whatever people. We need to have a whole number. And did you get 14,190? So let's write a good sentence. Oh yeah, are you using the subtract sign in the exponent? No. Yeah, there's two negatives, right? So when you look on your calculator, do you see there's a little negative under the 3? And the subtract sign. We're not subtracting any numbers, so we don't use the subtract sign. We're putting in a negative number, so you got to use the negative underneath the 3. All right, last part of the lesson. Okay, so here's a special type of exponential growth that happens a lot in nature where something's not growing infinitely. It's growing, but then there's a point where it flattens out. So like an obvious example, well, let's say you're an FFA, right? And you just picked up a cute little animal that you are going to raise to then go off to auction and go on my dinner plate, right? And so when you start with the animal, you weigh it. And let's say it weighs 50 pounds. The first weeks, what's happening to that animal's weight?
Getting fatter.
It's going up quickly, right? Will that animal forever grow quickly in terms of weight? Or will they eventually reach a weight and then flatten? Right? Like it eventually reach the weight it needs to be, and then it's not going to keep increasing, right? So do you see this graph? Think of it like the weight, and then eventually it becomes adult pig or cow, and it stays whatever weight it is till it's on my dinner plate. So this is called a logistic growth model. So a logistic growth model grows quickly and then it flattens out. And notice there's a horizontal asymptote. So it grows quick and then it follows the horizontal asymptote. Here's the formula. C is that horizontal asymptote. So let's say the average weight of a cow is, 700 pounds. That C then would be 700 pounds because that's what it will be like as you go on in time, right? A is the initial amount, right? R is the rate. X is the time. And E is a number in your calculator. Oops, that's the rate, and the x is the time. All right. Now, for these examples, I know, right? I'm trying my best. All right, let's look at it. So, a disease begins to spread in town of 20,000 people. That's awful. After T days, the number of people who have been infected by the disease is modeled by the function below. Using the function, find the number of people infected after 10 days. So, using this model, 20,000 represents the end amount. Like if everyone was infected in the town, you couldn't get bigger than 20,000. That's how many people there are. 1,150 are the initial amount of people that are infected. At what rate is it being infected? 95% per day. Big time, right? So, how are we going to answer this? Is we substitute in $10 for T. Now, it's going to take some skill and listening to know how to type it in your calculator. So, we're going to start with 20,000. And then we're going to open up a parentheses for the denominator. In the denominator, you're going to have 1 plus 1,150 to the exponent, parentheses, negative 0.0, no, not 0, what is it? Oh, E, I forgot the E, that's really important. E Now, is this an example that you have to round to a whole number?
Yes.
Correct. So again, why must it be a whole number? Because we're talking about people. You can have 0.85 people being infected. Number 8. Shh. The population in millions of a country from 1850 to 2000 is modeled by the equation below, where T is the years since 1850. Use the function, find the population of the country in 1920. So, if I was going to understand this, the most this country will ever be in population is 135 million. Right now, how many people are there? 58 million. At what rate 2.5% or 0.025, and then T is in years. So we want to know in 1920. So 1850 to 1920, I have to subtract, how many years is that from 1850 to 1920? 70. All right, see if you can use your calculator. See if you can use your calculator to find it. Be careful, because the number is in millions, the decimal is actually whole numbers. I'll tell you what that means. So first, did you type it incorrectly? All right, shh. So let's say this is what you saw in your calculator. Did you see that in your calculator? 12.185. Did you type it incorrectly?
Oh, I see it.
Now, you might say that, wait, you can't have 0.18 people. But the difference is, this is in millions. So 12.185338 million means 12,185,338 people.
That's what I got.
So because it's in millions, we can move the decimal to a whole number. So I made sure there are 6 numbers after the decimal, so that I have a whole number in terms of how many people will there be in 1920. All right, this is your first lesson on growth and decay. Mr. GMAT, over now.